I have a question. How many of you are still fully private cloud? Private cloud. 2, okay. How many are you fully public cloud? Okay. And how many are you multi or hybrid? Okay, interesting. So what I'm going to talk about is our cloud migration in a little bit more detail. And some of the lessons we learned during that migration and how we operate our platforms in the public cloud. So New Relic, as a company has been around since 2009. And from 2009 to 2016, the company built our technology on technologies like Docker, Apache Mesos. We developed our own deployment tools, one called Centurion, which I think we did actually open source. And we were running on Flatcar Linux hosts. And during this period, the entire architecture was built in one data center as one single instance, running on hundreds of servers. And so as we started to introduce new capabilities, we started to obviously having to scale out the solution, and we ended up scaling to 3 data centers with thousands of servers. And we started to actually run into physical limitations within the data center and data center floors, because you have to keep certain proximity to your data, right? Particularly in a streaming platform like New Relic. We also started to see our architecture showing signs of limits and bottlenecks, right? Because again, even across 3 data centers, we were still running a single instance of New Relic. And so we had a whole bunch of challenges. One is we had too many engineers focused on managing hardware rather than delivering software and value. 2, the single instance was a significant issue because we were running limits into some of the different software components that we depended on, for example, like Kafka. And really those choke points within that architecture, we had to think about what we were going to do to move to a distributed multi-instance based architecture. So something had to give, and we evaluated a number of different options, and we decided to transition to the public cloud. Now, why did we choose the public cloud? Number one is we wanted to eliminate scaling issues, right? We wanted to get out of the hardware business, racking and stacking hardware. And number 2, the behavior of our platform, we actually end up with we need surge capacity, right? Because different customers will send us data at different points in time. Some will have, for example, sales events. We have a lot of e-commerce customers that have sales events, and they'll require us to burst our capacity. So we really wanted to take advantage of the public cloud's ability to fire up instances for us as quickly as possible, right? Using technologies like auto-scaling. And that would allow us to manage our costs a lot better as well. Another benefit shifting to the cloud is we would take those hardware engineers and turn them into software engineers, right? Without committing additional headcount or resources. And finally, we leveraged the cloud migration to actually re-architect our platform, right? So we're doing 2 things here. We're migrating to the cloud, but we're also re-architecting the platform to better utilize that cloud platform. I'll take questions at the end, if there are any. So before we talk about the architecture we moved to, let's talk about the architecture we started with, right? This one little diagram, it looks complicated. It's not very complicated. Data sources is where the data comes from, right? And we talked about the different telemetry data types that we ingest. We had a firewall tier. We also had our ingest tier. That's where we initially buffer the data. Then we have producers that take that data and send it into Kafka, right? And we have I don't know if it's hundreds or thousands of Kafka topics, but lots of them, right? And that's where we ingest, that's where we persist the data, and then the consumers pull the data off those topics and send them to various places. One place in particular is our New Relic database, right? Which is our own proprietary scale-out solution. And then you have the data retrieval tiers, so that's where things like the GraphQL services run, things like some of the analytical services like Lookout and so forth, that pull data out of the database and then make it available to you to visualize and analyze and make sense of that data. Now, even with this architecture, this is one single instance, right? So imagine supporting all customers in New Relic with one single instance. What do you think could go wrong? Scalability and reliability challenges, noisy neighbor scenarios, right? So at the same time, during this period, we had about 100 plus engineering teams. We had at this point about 800 services that we were having to support, manage, and iterate on. Our Nurgle database actually is a Java JVM-based solution, and we had 14,000 JVMs that we had to support. And so, yeah, we started to run in a whole bunch of limits. In particular, we started to run into limits with Kafka because we had one giant Kafka cluster where we were processing about 20 gigabytes of data per second. I think at the time it was actually the largest Kafka cluster in the world. And so because of this architecture, we actually ended up having quite a few incidents in around 2018 and 2019, right? Which fundamentally forced engineering's hand and architecture's hand to do something different. Outages weren't the only problem. No one wanted to deploy in this environment because deploys were just far too risky, right? When I remember my first presentation when I talked about deploys and rollbacks, it's not even a case of rolling back here. We couldn't get engineers to deploy. No one wanted to take that responsibility. And so that actually slowed down our innovation, right? Our job is to innovate, to create new features and new value for customers. So very clearly something had to change. So what did we do? We heard about this architecture that AWS talked to us about called the cell-based architecture. I don't believe it was invented by AWS. There's some very old academic papers that talk about this architecture. And so what is a cell-based architecture? Fundamentally, it's actually pretty simple. It's just architecting based on fault domains, isolated fault domains. So what happens is the workload gets partitioned across different cells. So if you have 100 cells, as an example, and one fails, well, you lose 1%, right? Pretty simple math. Now, for a cell architecture to function, you have to have a scalable and efficient way to route traffic, right? And you have to have rules and decisions to be able to distribute that work across the different cells. And so what we use for that within New Relic is actually Cloudflare workers. So when you hit a New Relic endpoint, you're actually hitting a worker within Cloudflare, and that worker implements the logic which it grabs from this Wayfinder service to determine where your data ends up within the cells. And we have a standard sharding strategy, which is based on account number and data type. So for example, if you have 10 accounts and you're sending 4 different data types, it's very likely that your data will be spread across most of the cells within the environment. And there's lots of benefits to a cell-based architecture. One is we can reroute traffic very easily by just adjusting the rules in real time. So when we adjust the rules in Wayfinder, that will get picked up by the Cloudflare workers, and we can just redirect traffic very easily. We can also drain cells. So if we wanted to put a particular cell into maintenance, we can drain that cell and move the workload to a different cell. And we can also upgrade cells, right? And we can scale cells independently. So we actually have within New Relic different types of cells with different scales, right? So far we've talked about the benefits of cell-based architectures, but there actually is some significant downsides. The significant downside is maintenance, right? Anytime you take one thing and split it up into a sum of parts, there's a lot more work to do to manage and maintain that. And so we spent quite a lot of time up front solving for toil within this architecture by automating the life cycle of cells, right? And so we use, these are the three capabilities we rely on to manage these cells on a day-to-day basis. We use Argo and Argo workloads to build and decommission our cells. And those workflows will also trigger automation within Terraform to be able to manage the cloud providers' resources as well. And we've made all this available to engineers as self-serve capability, right? So if the engineers need the capability to do this, there's some authorizations necessary to have the permissions, but they can service their own needs, right? So there's no hierarchical kind of organizational structure here. Another foundational and another key capability we created is Kubernetes controllers and operators, right? So the fundamental foundation for a cell is a Kubernetes cluster. That's how we benefit from the auto scaling capabilities. And within AWS, we use EKS for this. So we built about a dozen in-house controllers to help us manage the control plane upgrades, the Argo application generation, some of the certificate management, and a lot more. But I can't go into too much detail here. So what's the cell-based architecture allowed us to achieve in terms of scale, right? So we've talked about a lot of these hero numbers today. The 5 billion data points per minute, that's what, at the time that this presentation was produced, that's what we were doing at peak. We do a lot more than that now. We have 180 petabytes that we ingest per month, and we service 160 billion HTTP requests per day at peak. And this fundamentally would not be possible without a cell-based architecture. We would have drowned before then. What about queries? And I've heard from some customers that we need to increase our query limits, right? Some of our customers use a bit of a long tail, right? Our default query limits work for probably 80–90% of customers, and in the next 10% we need to raise them. So if you do have issues with query limits, please speak to your account teams. So what do we support at the moment? 5.2 trillion events that we inspect per minute, right, across all customers. And 15.6 million query processes are executing. So those JVMs that I talked about, right, to support those queries. These are all the units of work that go into answering a query. And what do we consume in terms of resource? So at the moment, we've got 170 Kubernetes clusters, give or take, 250,000 pods that we're managing, and 19,000 nodes. And one of the things we do within New Relic is, as Ganesh mentioned, we eat our own dog food. So we actually have a separate staging environment for New Relic that we use to monitor our production environment, right? And we also use a bunch of other AWS services. We use managed Kafka servers, as I said, EKS, and a bunch of RDS services as well. But you can imagine we use one of everything. Now, as you can imagine, right, we did this migration whilst we were still servicing our customers. It was all done completely online. There was never a time where we could take an outage. So how do you migrate from a data center solution to a cloud-based, cloud-native solution and re-architect at the same time? It was actually quite a massive undertaking. And the only real way we could do it is to observe. Fundamentally, that's what we had to do. And this is an example of one of those dashboards that we had developed at the time, not only to track the progress of the migration, but make sure that we're delivering the same or better outcomes for the customer, right? Based on availability, performance, error rates, and so forth. So, observability in any cloud migration is going to be key to making it successful. The other reason we did observability is because we knew that we were going to be, we're a public company, right? And we have to report profits or, costs, revenue, and so forth. So we had to manage our costs, right? Anytime you take something from on-prem and move it to the public cloud, there's going to be overlaps in terms of costs for a period of time. So we had to manage our costs quite meticulously during this migration. And one of the things we developed is insights into the cloud costs and how they were related to both the cells themselves and the services running within those cells and the teams responsible for those services. So we could see whether they were leaving money on the table or whether they were actually running efficiently and spending money efficiently. This is what the migration actually looked like. And this is actually real data. This is a real chart that we use to track it. And what you see on the bottom there is the first monolithic cell, right, that we started with, that blue shade. And you see over a 12-month period, we created new cells and we rerouted the traffic over a 12-month period to the point now where you see there's that monolithic original single instance disappeared, right? And really, again, this is a testament to the engineering skill that we have within New Relic, that we were able to do this whilst servicing our existing customers, but also growing the business and providing adequate levels of performance to our customers. So we migrated our ingest 100% in under a year. So what are some of the lessons? For us, the major lesson is, and we're in the business of selling observability, but again, this would not have been possible if we didn't have a staging instance that was monitoring this migration and tracking its progress, right? So observability is key if you're going to pursue a cloud migration or you're going to pursue a cloud re-architecture, right? Number two is don't plan for the happy path. Things are going to go wrong. And so what we learned pretty quickly is to operate in small sprints, get that feedback, learn from that, iterate. And fundamentally within New Relic, that's how everything runs these days. Because no one knows everything, right? We're continuously learning. The cloud's continuously changing, right? And so don't try and plan too far ahead. You have to learn in small batches. The third lesson was our cell architecture is actually, we made a deliberate choice to make it ephemeral, right? So we rebuild our cells roughly every 90 days within New Relic. And the reason we did that is we didn't want to get locked into a particular cell-based architecture. We wanted the ability to adjust it based on our needs and our customers' needs. And so what that means is we can take advantage of changes in the cloud provider and the services that they can offer us. So for example, we're going through a process at the moment where we're migrating our NRDB cells to Gravitron. And we're actually not having to migrate them. All we do is create a new cell template, and over a 1 quarter period, those cells, as they're rebuilt, get that new template and can now start consuming Gravitron, and we can start to see significant savings, right? And the last one is, this is, we still haven't finished, by the way. There's still more of our infrastructure and more of our services that we need to migrate, but the large ones that are consuming lots of data is done, right? And so you really need investment in planning and communication, and you need executive sponsorship to make this happen, because it will create a lot of internal toil for teams, right? And you need to be able to prioritize these migrations so that you don't lose focus and you can meet the intended targets.